In this video, we are going to learn about ENSO, E-N-S-O. If you break it, EN stands for El Nino and SO stands for Southern Oscillation. Because ENSO phenomena mostly occurs at the southern hemisphere, just right below the equator. And when you look at the term oscillation, it gives us a hint that something oscillates from one place to another or back and forth. If you want, you can pause the video and think about what could be that thing. Well, it's the temperature that we are talking about. And not just any temperature, ocean temperature. It is the ocean temperature that oscillates back and forth from warm temperature to cold temperature and vice versa. Now the next question that should be in your mind is, which ocean are we talking about? I'll give you a hint. It's the largest one, Pacific Ocean. You see, Pacific Ocean is this large pool of water that exists on the western side of the American continent and eastern side of the Asian and Australian continent. This large pool of water gets intensely warm due to the fact that it exists right at the equator. And we all know that the equatorial region receives great amount of sun rays all throughout the year. So far we have learned what and where ENSO takes place. Now it's time to know how it all happens. To understand how ENSO occurs, we will need to break it into 3 phases. That's how it will make sense, and step by step the concept will get clearer. The first phase is neutral phase. Actually, there is no such thing as a neutral phase when it comes to any of nature's phenomena. You see, nature has a constant ongoing cycle that has never stopped. But for our own understanding, we will have to create a neutral state where we can see how a particular thing starts and goes on. So the first phase among the 3 phases is the neutral phase. In this phase, the central Pacific Ocean is warm. Now let's bring in the trade winds. Trade winds are these winds that blows in the tropical region from eastern side to the western side. They are also known as tropical easterlies. So as we know that the equator receives great amount of sun rays, and that's what warms the Pacific Ocean. The trade winds pushes the warm ocean current towards the Asian side because trade winds blow from east to west, and that makes the western Pacific Ocean warm. You know the region around New Zealand, Australia and Indonesia. This region is called the Western Pacific Pool. Here the ocean temperature is warm. The warm ocean current affects the surrounding atmosphere by increasing the temperature as well as the moisture content. And we know that warm air rises high into the atmosphere. It is through the convection process, and that's how clouds are formed, and then it rains. The warm air then travels east towards Eastern Pacific Ocean. You know the region near South America, especially countries like Ecuador and Peru. The warmer air, when it goes up, it reaches the end of troposphere. And if you know, the top of the troposphere is cold. When warm air meets cool air, slowly it loses its moisture content and the air becomes dry. The dry air travels towards the eastern Pacific side and comes down over the Peruvian coastal region, making the region cold. This pattern of rising air in the west and falling in the east continues, and it is known as Walker circulation. So this was the neutral phase. I hope you understood this cycle. It's plain and simple. Now comes the second phase. It's called El Nino. So in the neutral phase, we saw that the trade winds played an important role in pushing the warm ocean current towards the western Pacific. Now in this phase, the trade winds are weak. Yes, there are few months in a year when the trade winds are weak. When the trade winds are weak, the warm ocean current do not get any kind of push. So what happens is, the warm pool of ocean water at the western Pacific slowly moves towards the central and eastern side of the Pacific Ocean. So this is where the oscillation term comes in. You see, the warm ocean current is replacing the cold ocean current that exists in the central and eastern Pacific. When I say replace, what I mean is that the cold water is dense and it settles down in deep ocean, and warm water goes up and takes over the surface of the ocean. Okay, I hope you're understanding. When this warm ocean current moves, everything that is associated with it, like the convection process, then the formation of rain cloud, everything moves along with this warm ocean current. What you will notice now is that the Walker circulation that we saw in the neutral phase, that one big looping pattern, it's now breaking into 2 parts. Just look at this loop. As a result, the ocean temperature near Australia is cool and there is no rain, though the inland parts of Australia witnesses severe drought condition. But on the other hand, near the Peruvian coast, the warm pool of ocean current brings heavy rain, flood to the American continent. So whenever you hear the word El Nino, immediately think of warm ocean current. And the third phase is La Nina. This is similar to the neutral phase. In this phase, the trade winds are strong. Since trade winds blow from east to west, hence it pushes the warm ocean current from the eastern Pacific towards the western Pacific. Now imagine this. Cold water is dense and it settles down in deep ocean. So that means the temperature of the ocean surface is warm. Now if the trade wind pushes the warm surface ocean current towards the western Pacific, the cold water from the deep ocean immediately comes up at the surface. There's a word given to it. It's called thermocline. Thermocline is the rising path of water temperature. And the rest of the process is same. We saw that in the neutral phase. Western Pacific region of Australia, Indonesia, New Zealand gets heavy rain, storm. The effect of La Nina is more on these countries than El Nino. So El Nino is a warm ocean current and La Nina is a cold ocean current. Remember that. If El Nino is at the eastern Pacific, then La Nina will be at the opposite region, that is Western Pacific. And it oscillates back and forth.